Boom shakalaka. It is started. Okay, cool. So how did everyone do on the preparation assignment?
Did it? Didn't understand it.
But you completed it, so that's good, right?
I did it. I completed it with reading just only through going back through the lesson and rereading 3 or 4 times just to figure out what the answers were. But like I said, I don't really understand, and I don't get why.
Yeah, no, I feel the same way with this one. But I mean, I guess being able to answer it means you can understand it. You just can't explain it.
Well, yeah, but that's only because it's in the lesson. You have to read the lesson. But
That's true.
yeah, but when you're trying to figure out a concept,
Yeah.
I don't know. To remember it later is difficult.
The thing that aggravates me is it's like they give you the answer in the problem, and with normal math, they don't do that. You like never get the answer in the problem.
Right.
So I get super confused because they're like, "Oh, this is the answer," and then they ask you that question, and I'm like, that can't be the answer.
Well, and this week I went over the homework because I really did not do well with it. So I went over the homework with our TA and asked him a couple questions about what the finals were going to be and stuff, or the unit quizzes, the unit tests. And basically, he said that the unit tests were going to be a culmination of everything we're doing up to that point, and then the midterm and the final are going to be a culmination of everything midterm. So anyway, basically, we have to know all this stuff, and if you don't understand it, to try and know it for that midterm later is where I get all confused. Because if I don't know it, if I don't get the concept or see the picture of what it's trying to say, then that's where I'm like, never going to get it. So.
Yeah.
Anyway, so if anybody has any points on this, that would be a good idea to figure out. But otherwise, I figured it out, but it's not. I don't know.
I think the only one that we actually like, if no one has any questions, like have to go over is 7D, because it says to compare the means that we all got individually from our randomly selected 5.
Yeah.
Yeah.
Whoa. But I think other than that, unless somebody has a question, that's really all that I think we have to do.
Well, the other thing I noticed was I kept getting the wrong answer on 8D. And the thing that I figured out you had to do was you had to go and use all the decimal places. Like you had to go out 3 or 4 decimal places.
For 8?
For 8D. In order
to get in the video just said you had to do the standard deviation divided by the simple random sample, which was 10.
It's the square root of the simple random sample, but it doesn't come out right unless you use the full the full decimal points, if that makes sense. You have to go out like 3 decimal points or something. Anyway, just when we do our group test, we might have to do
that. I got you.
Okay. That makes sense. I get it now.
All right, so what did everybody get on that then? 7?
Yes. Sorry, let me pull it up.
I got 44,600 as my mean.
I got 48,640.
For my mean, I got 42,960.
40 what?
42,960. Yeah, 42,960. I'll just say it like that. That makes more sense.
Okay.
Tasha, yours was 4,600?
Mine was 44,600.
44,600, okay. Okay, we should have 3 more. Who else did it?
Did you guys do 7A?
Oh, Dylan's in here. I see him now. Hi, Dylan.
Hi, can you hear me?
Yeah.
Yeah.
Yeah, sorry. Yeah, I just running a bit late. Sorry about that.
That's fine.
I didn't want to interrupt the heavy calculations.
Mm-hmm.
So where are you guys now?
We're
We're
just-
working on the preps assignment right now. We're just running over answer 7D. We're talking about the means that we all got for 7.
Okay, let me just. I just got to still open it. I'll get to all those places. You guys can carry on so long.
We need one more person to give it.
Oh, you need one more person.
Yeah, because we need to compare with at least 3 individuals and 3 of us. For example, so we need one more to complete the 4th.
Oh dear. Okay, let me see if I can find it.
Sorry.
That's fun. The internet is quite slow. So is this for are you on the preparation assignment or are you on
Yeah,
the
Yes.
okay. And it's for question number 7.
Yes. So do 7A and then share what you got.
Okay. Let me select file of the study solutions. Okay. Complete. Get 44500 for 7A.
Okay. So now we need to compare those 4 numbers.
What's up?
We need to compare the numbers we got, which I don't think Dylan heard. Let's give our numbers again so Dylan can hear them, so he can discuss it with us. Dylan, what was your answer again?
44500.
Okay.
44,500.
Yes. Tasha, what was your answer again?
Mine was 44600.
Okay. And then Melanie?
48640.
All right. So we
Does
got
Stephen or Bartholomew have a number?
They haven't said anything when we were trying to get it, so I have no idea.
So they are actually all normal because they're still relatively close to the actual mean
Yep.
Yeah.
because they're within that 1 or 2 deviation.
Right.
So I think we did it right.
Yeah.
I think that's what we were supposed to notice.
The only one that's a little bit far away is the 42960. But it's still within 1, I think.
I was like, it's either within 1 or it's just barely hitting that 2 mark. So I would still count it as normal.
Yeah, I decided to be abnormal a little bit.
Yeah, as long as it's less than 2, it's fine, and it's less than 2.
Yeah.
Wait, so it was 42 what?
Mine?
I can't understand him.
It's 42,960.
Yeah.
429. Yeah, so then it's still within 2.
Yeah.
Yeah. All right.
All right.
Oh.
As far as I can see.
So, do we want to start the quiz?
I'm good too.
I don't know. How does everybody feel?
I'm feeling confident.
All right. Well, let's start it. We'll talk through it.
Okay. I mean, talking through it as a group will probably help all of us understand it anyways better. I think that's how I feel. That's how it works with things. As you talk about it,
Yeah.
understand it better.
Okay, well, let's go through it together.
Yeah. All right.
I'm already lost.
You're already lost.
That's nothing.
Okay. So, question 3, when you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
Okay, so how do you figure that out? Because you put it in I don't know where you put it. How do you figure that out? I think it's normal, but I don't know if is there a
I am so flipping confused.
yeah, I don't know if is there a thing that we use to a graph or something that we used to put into that into? I can't remember.
Hello, guys.
Hello.
Hello. Oh man. Okay, you hear me?
Hello.
Hello. Hello.
Hello, who's there?
I'm Steven.
Hi, Stephen.
Have you started? Oh,
Yes, we're just starting right now.
okay.
We're just starting the
So,
quiz.
oh yeah. Okay. So question 3, right?
Yes.
Don't understand. So we'll go to the online textbook because that's where all the answers are.
I think that it couldn't be normal because we need a sample size of 30.
Yeah, but why is it normal? We got to know why. We got to know why. And how do you figure it out?
N stands for normal.
No,
I think it's skewed
I
right.
don't think. Yeah,
So-
I think it's skewed right.
It should be skewed right. That is what I think.
Yeah.
The first one.
Where's that? This is so. Wait. Okay. So. Let's see.
I have no idea how to figure it out.
The right skewed.
So
Okay.
when it's
No.
when the
No. Don't listen to me. I don't.
so when the histogram is right skewed, it means that the numbers closest to the axes are am I right? It's higher at closer to the axes, like from zero basically, and then as you go further down the x-axis, it's gonna drop. Well,
Yes. That's what skewed right means.
So here's something that says the central limit theorem says that if the sample size is small, it's not going to be
Normal.
even though we do not see the distribution of all samples, the sample size is if it's large, we can be assured that the sample mean can be considered normally distributed of the population. So, but if it's small, I think it's skewed one way or the other, but I don't know which way.
Yes. Yeah.
I think there's a table, a form, an Excel sheet or something that we can put that into, but I can't remember where that's at.
I mean, if I'm not mistaken too, though, like if the sample size is smaller and it's a normal distribution, it can still be a normal distribution, though. But like, if it's smaller and if it's skewed one way or the other, it's not going to be normal.
Yeah. If we compare the question 5, yeah, it's the same, but with the parent population normally distributed. So in that question, it gotta be normal.
Mm-hmm.
But in question 3,
What is the shape of the histogram when the parent population is skewed right?
Is the first one. So it tells us that the population actually is skewed right. That's why in a question it gives us the information that the parent population is skewed is right skewed. So if it is right skewed, then it's skewed right. So the first one.
Yeah,
Oh yeah.
because like with a small sample size, like say the sample is you have 5 people pick a number between 1 through 10. Okay, so like say like you get like for like a normal distribution, say like one person says 4, one person says 5, one person says 6, one person says 7, one person says 8. It's gonna be normal. But like say like you get this is a terrible description. Never mind. I don't know what I'm thinking. I don't know where I
Can I
really
share my screen?
Very good.
Yeah.
Can I
Yes,
share the
please.
screen?
what?
Yeah. Share your screen.
I don't
Bartholomew, not you.
know, Bartholomew. I'm like, I don't know what I'm doing right now. I don't know how to explain this.
So this is what happens when, let's say it is 0, everything, but when you put in the 5, you can see how the histogram looks like
Mhm.
on this chart. So everything has moved towards the right direction.
Put in 100 now.
But that's based on the data he has in the A column.
Right.
If you had different data in the A column, would it change?
Yeah, because it's if the parent population is right skewed, left skewed, or a normal distribution. So that's how it changed.
So are we saying it's right skewed then?
Yes.
Put 100 in there just so you can see the change, or the 1,000 or something.
Well, 100 is the next question. So
I
that
know. See, that's not, 100 should be normal, so that doesn't work on that histogram.
Uh-oh. Well, I mean, it's not the thing that he's doing isn't skewed to the right or whatever we need to do it for the question at the same time.
You got it right.
Yeah. I took the quiz just a couple of minutes ago, so it is skewed right.
Okay.
Yeah.
So you got, what did you get for the quiz, Bartholomew?
Yeah, I took the quiz. Yeah. And I got everything right.
You get, cool. Okay, so just give us all the answers and we'll just call it a day.
No, we can't.
No, because I need to learn it.
Fine, guys. No fun.
You have to remember, this is being broadcasted to our teacher. First off,
By the way, I did my homework third. I spent hours if the teacher is listening. Hours on this homework.
Right.
yeah.
All right, number 4. I think number 4 is 100. I think it's normal. I mean, sorry.
Yeah, number 4 is normal.
Because it's a large one.
Mm-hmm.
Number 5 is the same question, but it's normally distributed, so it's a low sample size. Does it still mean it's a normal distribution?
That's what I'm getting in my head. But apparently Bartholomew did it, so.
So the number 5, the answer is even in the question. It tells us that the parent population is normally distributed, so it is normal.
Normal one. That's what I thought. And then the number 6 should be normal then too, right?
Yeah.
Yes.
Yes.
Is that making sense at all to you, Melanie?
Yeah, sort of, yes. It's when it's left or right skewed that I get confused, because how do you figure it out? It doesn't tell you really, so.
I got
Oh,
that.
picture.
So is 6 normal?
Yes.
Yes, it is.
I agree.
So the n equals 100. What is it basically telling us when it says that then?
That tells you how many sample sizes of the sample that you're taking.
Mm-hmm.
Okay, so now you've got 100 sample sizes, and saying the distribution of the mean. What is the shape of the when the parent pop? So actually, that number is actually irrelevant. It's just the part that says it's normally distributed is actually all you're looking for.
Well, no, because sometimes it depends on your sample size and how it's distributed. So yeah, I don't know. Don't ask me.
No, you're fine. Which question are we talking about?
6.
Number 6. Well, any of them, these ones, all of them, they're basically the only thing that tells us the answer is that it says that it's normally distributed, it's right skewed.
Yeah.
So is number 4, is that also, it's meant to be right skewed, skewed right?
No, because that's the difference. Because there's a bigger sample size, and when there's a larger sample size, it makes it normally distributed.
Yeah.
The larger the sample size, the more normally distributed it is.
Okay.
When there's a small sample size, it stays right skewed. When it's a larger sample size, it becomes more normally distributed.
Yeah, like
All right.
so.
Okay.
So
There we go.
here we go. So going back to, remember the question we did with the means, and we had our own separate means in the preparation assignment? That's because we took 5 out of the larger number. And so we had different numbers. So like we skewed it one way or the other with a smaller number, where if we had taken all of them, it would have been a normal distribution.
It would,
All right.
Oh,
It makes sense. Yeah. Okay, cool.
oh my
At
gosh.
least we are learning something.
Okay.
Tasha, what were you saying?
I said, oh my God, stuff is clicking.
Yeah.
I'm glad. So we ready for number 7 then?
Yes.
So number 7
So
is
what's
just going over the things we just did in those last few questions. So before we talk about the answers, does everyone, like, looking over it, does everyone think they know it's number 7? And then so if they don't, we can discuss it.
I haven't read it. When is
Okay.
normally distributed? The data on the population distribution sample size, yes. Data are drawn from the population normally distributed sample size is large, yes. Sample size is small, no. So 1, 2, and 4?
Yeah, that's what I
Yeah.
get.
Yeah.
Yeah.
See? So you're figuring it out.
Yeah, 1, 2, and 4.
Yeah.
Thank you. Just nice to get the affirmation from the guy who got all this math.
Yeah. So are you understanding it a bit better now, Melanie?
Yeah, I told you, I get it. It just gets confusing. So yeah, let's keep going.
I got you. Yeah, so like you're like, I can do it now, but like come finals when we have to.
I can do it. I just don't see the point in it. And so it doesn't make sense. And so when it comes to asking a dumb question on a test, it's like, but that doesn't make any sense. So
Okay. Okay, I got it. You're fine.
If that makes sense.
No. That
Just before you start, ask the teacher to block his ears before you make that statement.
Teacher knows me. He knows I'm dumb. It's
You're
okay.
not dumb. We're just statistically challenged.
There you go. And I am that.
You're not alone.
I'm definitely getting a tutor for this week.
What?
I'm definitely going to get the tutor for this week. Just to
yeah.
make it a bit easier.
Okay, so
Number 8.
7. Okay, so now we're on 8,
I
Yeah.
think so.
and it's called the definition.
Sorry, what's that?
Oh yeah. Which of the following gives the best explanation of the central limit theorem?
It's
I think
number, I think it's 3.
Yeah, 3.
That's
It's
my
4.
my
Yeah, I was
guess.
gonna say I think it's 4.
Are you sure?
It's
Because I
4.
thought 4 was the other one.
It's 4.
Okay.
Yeah, I was just going to say 4 seems a little closer to what we've been talking about.
Okay, so
So when you go to the textbook, look at the summary.
mhm.
Oh, I read that wrong.
Okay.
Yes, 4.
I did large numbers, not central limit.
Okay.
My bad.
All right.
That's fine. as long as you look over and realize that, because like that's the thing is like math, like with math, a lot of the questions are designed to try to trip you up.
Yeah.
So like math is a lot of reading comprehension, if anything.
Oh, I know. Yes.
Okay. I did love large numbers, not the central limit theorem. I just need to learn to read.
Let X be a random variable.
Okay.
10.
So I'm good on 8.
Okay.
Okay, so we're on to 9.
Yes. Everyone's ready for 9?
Yeah.
All right. Use the following information to answer the next 4 questions. Let X be a random variable with population mean, I forget how to pronounce that thing, equals 10.
Sigma.
What?
The mu and
I think
sigma.
it's just a standard deviation.
Yeah.
Mean
So-
is mu. Standard deviation is sigma.
Yeah.
Okay.
That's what I was going to say.
Mean of the distribution.
Yeah.
So the mean
Yeah.
is 10.
So question 9, yeah. What is the mean of the distribution of sample means? It is 10, right?
Yeah.
Yeah.
I'm pretty sure it's 10.
Yeah. It's 10.
Yeah.
Good job, team.
Whoa.
Okay.
It's the next, I'm assuming if it's 10.
All right, question 10. What is the standard deviation of the distribution of sample means?
6.
No. Because
1.
this is the one where you do that the sigma divided by the square root of n.
Yep.
Okay.
Oh, it's 1 then.
Yeah.
Yeah.
Yes.
Yeah. Okay.
What is, wait, hang on, 36. Yes, it's 1.
That's the one thing I understand.
Right? How to do the math problem.
That
You
gets
seem to know that, so that's cool.
Give me a formula and I can plug and chug all day.
All right, so question 11. Regardless of the distribution of the population, if the sample size is large, what would be the shape of the distribution of the sample mean?
Norm.
Normal?
Normal.
Yeah.
Normal.
All right, and
Why? Wait, tell me why. No, regardless of the shape.
yeah,
No, regardless of the distribution. If it's large. Oh, because if it's large.
yeah, because if it's large. So
Okay.
what we talked about earlier. And then what theorem would justify your response to the last question?
Central limit.
Yeah.
Yeah.
Because if you scroll back up, it literally, that's the question they asked us about it. Like, what's the best explanation?
Yeah. Question 8.
Yeah, question 8. They already
Yeah. Yeah.
So,
explained
so
what
what's the difference, or why wouldn't it be the large number, the law of large numbers?
Because that one is, as the standard deviation gets smaller, you get closer to the actual mean. And that one, we weren't talking about the standard deviation. We were talking about the sample size.
Got it. Okay.
Okay. Sorry guys, I've got to go. I'm late for youth. But thanks.
Okay, yeah,
Thanks for
sorry.
help.
Thank you. Yes, we did it together. Good job.
No,
Let's hope we
my,
get it
my
right.
fault. But thanks guys. I appreciate it. Keep well.
Yeah,
All
yeah,
right. Thank you.
yeah. If I just turned it
Bye.
in, 100%.
Are the rest of us all done? Did we get it all right?
Yeah, I
I
turned it in.
All right. Sounds good. Has anybody taken the homework test? Is it similar?
I have not yet.
I haven't gotten there yet.
Me either.
Not
Okay.
yet.
I'm a little slow this week trying to figure it out because
Me too. We're selling a business, so it's killing me.
Yeah, you talked about that. I'm sure once you get that out of the picture and you can focus a little bit more on the math.
Oh, I am so looking forward to 13 days from now. So I'll be a whole new person. Well, at least we hope I will be. All right. Well, thank you, everybody.
Yeah, good job. I think we did good.
All right, Josh, you got it Thursday again?
Yeah.
All
Yeah.
right.
So
Sounds good.
we're all doing good with explanation. I'm going to stop the broadcast now, I guess. We can talk a little bit more after that.